So welcome, this is the second part for the questions based upon logarithms. Now question number 16, the question is solve. Solve for 2 times 4 power x plus 4 power negative x equals to 3. So what am I going to do that? Let 4 power x equals to y. So what does that becomes now? It becomes 2y plus 1 upon y equals to 3. So it becomes a quadratic. 2y square plus 1 equals to 3y. So it becomes 2y square minus 3y plus 1 equals to 0. Factorize that one. It becomes 2y minus 1 times y minus 1 equals to 0. So what do I get the values of y? Y equals to either 1 upon 2 or y equals to 1. But what is y? Y is 4 power x. 4 power x equals to 2 power negative 1. 4 power x equals to 2 power 0. 4 is 2 power 2. 2 power 2x equals to 2 power negative 1. So this gives me x equals to negative 1 upon 2. So this gives me 2 power 2x equals to 2 power 0. This gives me x equals to 0. Now that's 16 question part A. Now there is part B also for this question. So question number 16 part B. Now what is he asking? Solve. Solve a power x equals to e power 2x plus 1 for a is greater than 0, giving x in terms of a. X in terms of a. Then, and also, that is the first part, and the second part is find a so that equation has no solution. Have no solutions. So how should I do that? For the part 1. So equations have no solution for the part 1. So now part 1, a power x equals to e power 2x plus 1. A power x equals to e power 2x plus 1. So applying ln on both sides, ln a power x equals to ln of e power 2x plus 1. So x ln a equals to 2x plus 1 ln e. So what is the value of, I want to find the value of x. So 2x equal, then x ln a. So I take common, x ln a minus 2x equals to 1. Take x common, ln a minus 2 equals to 1. From there, what do I get the value of x? X equals to 1 upon negative 2 plus ln a. That's going to be the answer. Now next part of the question, what is he asking? Find the value of a so that it does not have any solution. So what is the case is? Denominator should be equals to 0. So minus 2 plus ln a equals to 0. If the denominator is equal to 0, there is no solution at all. So ln a should be equals to 2. So a should be equals to e square. If a is equal square, the equation will not have any solution at all. That is question number 16. Coming to question number 17. Solve. Solve this equation. What is that? 2 to the power of 2x plus 3 equals to 2 to the power of x plus 1 plus 3. So it can be written as 2 power x whole square times 2 power 3 equals to 2 power x times 2 power 1 plus 3. So what am I going to do? Let 2 power x equals to y. So it becomes y square, 8y square minus 8a minus 3 equals to 0. So factorize it out. 4a minus 3 times 2a plus 1. 2a plus 1 equals to 0. So a equals to 3 upon 2 or a equals to negative 1 upon 2. So now when a means 2 power x. 2 power x equals to 3 upon 4. It is not 3 upon 2. It's going to be 3 upon 4. Or a equals to negative 1 upon 2. So 2 power x equals to 3 upon 4. So apply log on both sides. Log 2 power x equals to log 3 upon 4. So x log 2 equals to log 3 upon 4. So x equals to log 3 upon 4 upon log 2. This is one answer. Another answer is nothing but what? 2 power x equals to negative 2 power x equals to negative 2 power 1, 2 power negative 1 or negative 1 upon 2, which is not possible because 2 power x cannot be any negative number. It is always going to be a positive number. So this is not possible. So my only one answer is log 3 upon 4 to the base 2. This is going to be the answer. So, but we want to simplify this one further. So what I can write it as? It can be written as log 3 to the base 2 minus log 4 to the base 2. So we can write it out the answer in this form also. And still simplify it out, log 3 to the base 2 minus log 4 can be written as 2 square to the base 2. So it becomes log 3 to the base 2 minus 2 log 2 to the base 2. 2 log 2 to the base 2 is 1. So final answer is log 3 to the base 2 minus 2. This is the final answer for question number 17. Now question number 18. Solve. 2 ln x whole square equals to 3 ln x minus 1. So again this is going to be a quadratic. So it becomes 2 ln x whole square minus 3 ln x plus 1 equals to 0. This time I do by factorization. 2 ln x minus 1 times ln x minus 1 equals to 0. So ln x equals to 1 upon 2 and ln x equals to 1. So x equals to e power 1 upon 2, x equals to e power 1. Now question number 19. A sum of $100 is invested. We are investing $100. What is the question over here? It is invested at a rate of compound interest, which is compounded annually. Compounded annually at the rate of 5% per year. Find total value after 20 years. That is the first part. And in the second part, if at all it is compounded monthly. If at all it is compounded monthly at the rate of 5 upon 12% per month. 5.12% per month. Then what is he asking? Find minimum number of months. Find minimum number of months. Minimum number of months for the value of investment to exceed V. V was the value from compounded annually. So first of all, we'll calculate for A, which is compounded annually. So V equals to 100 times 1 plus 5%. 5% means 0.05 whole to the power of how many years? 20 years. So it's going to be approximately $265.33. That's going to be the answer for the first part. For the second part, what is going to be the second part? It is compounded monthly. So 265.33 should become less than compounded monthly 100 times 1 plus 0.05 upon 12 whole to the power of how many months? 12t. So what am I going to do? It becomes 2.6533. That 100 you bring this side, it becomes then it is 1205 upon 1200 to the power of 12t. So then apply log on both sides. So when I applying log on both sides, log 1205 upon 1200 whole power 12t should be greater than log of 2.6533. So 12t should be greater than log of 2.6533 divided by log of 1205 divided by 1200. Simplify this one. You should be getting it out t greater than 19.556 means approximately 235 months. Because he's asking in months, our time should be always in months. That's going to be the answer for question number 19. Coming to question number 20. Solve. What is the equation? 9 log x to the base 5 equals to 25 log 5 to the base x in the form of 5 to the power of p upon q. The answer should be in this form, 5 to the power of p upon q. So 9 log x to the base 5 equals to 25 upon log x to the base 5. So it becomes log x to the base 5 equals to whole square equals to 25 upon 9. So what does that becomes now? Log x to the base 5 equals to square root of 25 upon 9. Square root of 25 upon 9 is plus or minus 5 upon 3. So log x to the base 5 equals to plus or minus 5 upon 3. So x equals to 5 to the power of plus or minus 5 upon 3. Question number 21. Solve ln of x plus 3 absolute value equals to 1. So what does that becomes? So ln of x plus 3 equals to 1. So whenever it is absolute value, so x plus 3 should be equals to either positive 1 or x plus 3 should be equals to negative 1. So x plus 3 equals to e, x equals to e minus 3. X plus 3 equals to e power negative 1, x equals to e power negative 1 minus 3. These are the two values. Absolute value means it can either be positive or negative. Coming to question number 22, again solve absolute value of e power 2x minus 1 upon x plus 2 equals to 2. So how should I be able to solve this one? I am going to draw the graph for this one. So when I'm trying to draw the graph from the graphing calculator, I get it out in this way, and over here a graph approximately equals to this shape. This is the shape of the graph. To be more precise, this graph shape should be in this way, and y equals to 2. Where is y equals to 2? Y equals to 2 is a straight line. Now we found 3 points of intersections. So those 3 points of intersections are there. From the graphing calculator, you can find those 3 points of intersections: negative 2.50, negative 1.51, and 0.440. Check by using GDC. Coming to question number 23. In 23 again, it is given that the growth of a bacteria. The growth of a bacteria follows this one formula. The population of that one is given by n equals to 650 e to the power of kt, where t is in the time in minutes. Then the number of bacteria doubles every 20 minutes. Doubles every 20 minutes. The question is find k. So it doubles every 20 minutes. And the time taken is nothing but what? 20 minutes over here. So n becomes nothing but what? 2, because it becomes 2 in 20 minutes. If at all I am going to take it as, its starting is nothing but what? 650. So how should I do right then? Let me do it out slowly. So at t equals to 0, it will be the starting one. So n equals to 650 times e to the power of 0. So starting one is going to be n naught. N naught is going to be nothing but what? 650. Now it doubles in 20 minutes. So it becomes 1300. 650 times 2 is 1300. 1300 in 20 minutes. So 1300 equals to 650 times e power k times 20. So 2 equals to e power 20k. Apply ln on both sides. Ln 2 equals to ln e power 20k. So ln 2 equals to 20k. K equals to ln 2 upon 20. That's the value of k. Now coming to question number 24. F of x is given as ln x plus ln x minus 2 minus ln of x square minus 4. First one is nothing but what? Express f of x in the form of ln of x upon x plus a. And part B, find f inverse of x. So first part A, f of x equals to ln x plus ln x minus 2 minus ln of x square minus 4. So multiplication becomes addition and division minus becomes division. X times x minus 2 divided by x square minus 4. So x square minus 4 can be written as x plus 2 times x minus 2. X plus 2 times x minus 2. X minus 2, x minus 2 cancels. So what does that becomes? Ln of x upon x plus 2. Then he's asking find f inverse of x. So I get y equals to ln of x upon x plus 2. So x upon x plus 2 equals to e power y. So x equals to x e power y plus 2 e power y. So x minus x e power y equals to 2 e power y. Take x common, 1 minus e power y equals to 2 e power y. So x equals to 2 e power y divided by 1 minus e power y. So that is only going to be my f inverse of x. F inverse of x equals to 2 e power x upon 1 minus e power x. And finally, question number 25. F of x is given as e power x minus 1 minus x. Then find minimum value of x, minimum value of f, and part B, prove that e power x is greater than or equal to 1 plus x for all values of x. This is a symbol for all values of x. What am I going to do that? I am going to draw the graph for this. When I use a GDC to draw the graph for this, it comes in this way. So you can see that the minimum value is always at x equals to 0. So minimum is at of f is equals to 0. Then the next part, what is he asking us to prove it out? That it is always e power x minus 1 minus x is always e power x is always greater than or equal to 1 plus x. So we can see that e power x minus 1 minus x is always a positive function. It is never becoming below the x-axis. So from there we can write that e power x is always greater than or equal to 1 plus x. From the graph itself only we can say that this graph is always positive. It is never going to the negative y-axis. So therefore e power x is greater than or equal to 1 plus x. So that completes this revision for logarithms. See you in the next video. Bye.